Hi, welcome to All Tech Fusion. After a long time, I'm making new playlist. This playlist related to data structure algorithm. So in this, we'll cover most of the topics related to the data structure algorithm. Now, prerequisites for this is you should know at least one programming language like Java, JavaScript, C, C++, anything. Any language is okay for me. But during this playlist, we will be doing coding in JavaScript only, and in between, we will switch to the another language as well. Now, starting towards the data structure, first topic or basic topic comes in mind is complexity. Means why we are using the data structure. Means why we are learning the data structure algorithm. The reason is that time complexity. So we'll start today with time complexity. Before moving towards the time complexity, we'll check for three notations, that is asymptotic notations. These asymptotic notations are nothing but big O notation, omega notation, and theta notation. So we'll go through each and every notation in detail, and then we'll find out which notation we use majorly and what is the use of another notations and what is the difference between these three notations. Then time complexity measurement will check how to measure the time complexity of particular code, and then we'll at last will be focusing on the space complexity. So this is the agenda for today's video. I already created a blog for this topic. So we'll go through this blog one by one. Now, as we are concentrating first on the asymptotic notations, the first notation is big O notation. Now, what is exactly big O notation stands for? Big O notation represents the upper bound of the running time of an algorithm. And if we move towards the definition, then definition of the big O notation is if f of n describes the running time of an algorithm, then f of n is big O of g of n if there is positive constant c and n0 such that 0 less than or equal to f of n less than or equal to cg of n. That means I know no one got nothing because definition is somewhat complex, and when I read it first time I was also a little bit confused. So no worries, we'll try to analyze this definition. Now here f of n is there and cg of n is there. So what definition actually is telling to us that we have to find out the value of c and n such that f of n lies between 0 to cg of n. That means for the value which we are finding out for n, so for that particular value and value above that means n0, for all the values it should fulfill this condition. Then we can say that f of n is big O of g of n. I think many of people still confused. So for that I am having one example. So we'll take one example. Now here I am saying that f of n is equal to n square plus 1 is big O of n square. Now again I am repeating the sentence, n square plus 1 is big O of n square. Now how? We'll check. Now consider f of n is equal to n square plus 1, g of n is equal to n square. Now I am taking n as a 2, then f of n is equal to 4 plus 1 is equal to 5. Now f of n is 5 and c g of n is equal to c into 2 raised to 2, that is 4. So c into 4. Now if consider c is equal to 2, then c g of n is equal to 8. That means now f of n is 5 is lies between 0 to 8. That means it is between 0 to 8. It means it is lying between the 0 and Cg of n. Hence, n square plus 1 is big O of n square. I think now it's clear to all. From graph also we can check that Cg of n is always lying above the f of n, means it is at upper boundary that than f of n, and f of n is lying below Cg of n. So this, through this example we got to know that we can say the function f of n is a big O of g of n only and only if f of n lies between 0 to Cg of n. That's it. So that is the definition and that is the explanation for big O notation. Now omega notation is approximately opposite to the big O notation. Means for example, big O notation is giving us the upper boundary, then omega notation is giving us the lower bound of running time of an algorithm. Now definition. Let G and F be the function from set of natural numbers to itself. The function f is said to be omega of g if there is a constant c and natural number n0 such that c g of n lies between 0 to f of n over. So again I think definition is not that much clear. So again same, we have to find out value of c and n such that g of n means cg of n should lies between 0 to f of n. So in this case f of n will always lie above the cg of n. So for that the example is f of n is equal to n cube plus 1 and g of n is equal to 1. Consider f of n is equal to n cube plus 1. So now I replace n by 1, then if n is equal to 1, then f of n is equal to 1 cube plus 1, that is 2. Now f of n is equal to 2 and g of n is equal to 1. Hence n cube plus 1 is omega of 1. Hence here we can say that f of n is omega of g of cg of n. And from graph is also telling us the same, that f of n lies is appearing above the cg of n and cg of n is lies between 0 to f of n. So this is called as omega notation. Now theta notation. So again the definition is there. Let g and f be the function from the set of natural numbers to itself. Then function f said to be theta of g if c1 g of n less than or equal to f of n less than or equal to c2 g of n. Again it is a definition, I know. So always definition is complex and not able to understand the definition. So I will explain in the simple words that theta notation is the combination of big O notation and omega notation. So from the expression you can observe that c1 g of n less than or equal to f of n. That means it is representing the omega notation. And second one is f of n less than or equal to c2 g of n. It is representing the big O notation. Hence it is a combination of both notations, and from graph also you can check f of n is sandwiched between two notations. Hence it is called as a theta notation. Now this is all about the asymptotic notations. Now we'll move towards the comparison. Now for comparison purpose I am having one program which will search the elements from array for our element. Means we are giving one, passing one element, and it will find out that index of that element in that particular array. So for that one method is there, search element. We are passing elements array, and then n means length of the array, and x means the element which we want to find out in the array. Now what happens if we find out while searching, if we got our element at first index, then it is the best case that we are getting our element at first index. It is called as a best case, and best case is nothing but the lower bound of an algorithm. Hence, it is called as a omega notation. We are getting lower bound, that means it is a omega notations. Hence, it is called as a best case also. Now, second one. While searching, it may possible that the element which we want to search, that is 88, may be at middle position or middle index of an array. So at that time it is a average case. Average case, that means it is a theta notation. It is related to the theta notation. And now last one is worst case. That is nothing but our element will be on last index of an array, or it will not be present in the array. So in this both condition we are getting worst case scenario, that is a upper boundary. Hence it is called as a big O notation. Out of these three, generally we use worst case because best case will always give you the least scenario, that is least and best case, but worst case will always show you the all the scenarios, means all the scenarios, and we can find out the time complexity as per the worst case scenario only. Hence we generally use worst case, that is big O notation, to find out the time complexity. Now this all about the asymptotic notations. Now the main point is time complexity. So we'll try to understand in simple language what is the time complexity. Imagine team of 100 employees in which you have gave your pen to one employee. You have to find out that pen without knowing to whom you have gave it. So in this scenario, first scene is, or first condition is, you will go and ask first person that you are having a pen with you, and you will ask the same person about other 99 persons that they are having the pen or not. So in this case, time complexity is n square. Then second scenario is, you will go and ask each member individually. Then you will get to know that okay, this person is having the pen. So at the in this time, the time complexity is n, that is O of n. And now third scenario is, you will divide the team in two groups, and then you will ask in which group the pen is there, left or right. If they said yes in left, then you will eliminate the right group and you will take left group. Again, you will divide it into the two groups, and again you will ask left and right. So like that you will go on. And in this case, the time complexity will be O log n. So this is the basic example I have given to you for understanding the time complexity. But actually, time complexity of an algorithm or code is not equal to actual time required to execute particular code, but number of times a statement executed. I think again it is somewhat confused or confusing statement, so I think it is better to understand it through the example only. Time complexity considers how many times each statement executes. So we'll take example now. I'm opening the code, time complexity. You can check over here. I think it is straightforward, but we'll go through each and every code now. O of 1, like here we are printing hello world. So as we are printing hello world over here, it is printing only one time, hence its time complexity is 1, that is O of 1. Now second one, second program, we are printing hello world 8 times. You can check here, hence its time complexity is O of n. And now I am dividing it by 2. So we are printing same hello world now 4 times. Hence the time complexity is O log n. So this is the simple example we are taking for understanding the time complexity. Now we'll move towards the measurement, time complexity measurement. Again, for time complexity measurement, we'll take one scenario, that is, consider a system with following specifications: having single processor, 32-bit, then again 1 unit time for arithmetic and logical operation, and 1 unit time for assignment and return statements. Means, for example, arithmetic means a plus b is arithmetic operation, so it will consume 1 unit, and returning a value will consume 1 unit, and again assigning means sum is equal to 0 will consume 1 unit. So like that, it will the consumption of the time will be there. So now we'll take the example. Here you can check in first example we are simply doing the addition. So in this case, 1 unit will be for a plus b, that is arithmetic, and 1 unit will be for return statement. Hence time complexity of the program is O of 2, that is 1 plus 1, that is 2. Now again 2 is a constant, hence it is O of 1. Now in second example, what we are doing, we are passing one array and we are summing the array. So now here sum is equal to 0. It means it is an assignment. An assignment have 1 unit time. Then here we are doing arithmetic operation as well and assignment as well. Hence 1 unit for assignment and 1 unit for arithmetic operation. And it will replay for n times because the loop is there. After that, again here sum is equal to sum plus array of I, that means one for assignment and one for arithmetic, and again into n, because it is also replay, or it will also iterate for n times, and one for return statement. Now time complexity is equal to 1, that is of sum, then 2 into n plus 1, that is this one, 2 why 2, because uh, 2 units, one for assignment and one for arithmetic, into n means n times the loop will run, and 1 means for last occurrence, which we generally exclude, or we does not care about that particular entry iteration. So that iteration we are taking over here, and plus 2 means one cost of sum is equal to sum plus array assignment and one for arithmetic, and into n because for n times it is iterating, and plus 1 for returning statement. So when it happens 4n plus 4, that is O of n, that is linear. Again, this is the way through which we are calculating the time complexity. It is not necessary that 1 unit will be there for assignment. We just take the scenario to calculate the measure the time complexity. So time complexity always differ system wise, and execution times are specific to a particular computer. So system wise is differ the execution time also. And now the last but not least, space complexity. Generally, many people says that auxiliary space is nothing but the space complexity, but it is not like that. Auxiliary space is the extra space or temporary space used by the algorithm, and space complexity of an algorithm is total space taken by algorithm with respect to the input size. Means space complexity includes both auxiliary space as well as input space. And space complexity depends upon the variety of things like programming language, compiler, even machine running the algorithm as well. So that's all about the time complexities and asymptotic notations. And I think this much is there for the first video. Now from second video onwards, we'll move towards the next topic. And if you feel that still you are confusing at some points, then please drop the message in the chat box and mention the name of the point where you are feel that it is confusing. I will again try to make small video or short video on that point. I will share this link, blog links also in the description and also code snippet as well. Thanks for your patience.